Okay. As Mark said, I'm here as an independent consultant with ARC Associates. For the past 40 years, I worked for the Dow Chemical Company. So I don't have a disclosure slide like Tom had up there, but the opinions expressed by myself are not that of the Dow Chemical Company. Okay. But it is all experiential based on 40 years of experience in the chemical processing industry. And the topic here related to predictive analytics in situational awareness conditions. My presentation right now is a different metric. So the previous presentation was about how to use manufacturing IT solutions to fundamentally make closed loop decisions for productivity purposes. And my presentation is going to take a different metric, a very personal concern to me, and it has to do with process safety. So the theme here, the convergence of automation systems, manual operating discipline and operational management systems can provide a needed breakthrough in process safety performance while improving operational excellence in asset utilization, quality, and productivity. So what you saw with Shell was an example of taking existing technology today and putting all the pieces together and getting a higher level of operational performance. My proposal to you is the solution that you saw with Shell. Why are we not applying that same capability to improving process safety? And I'll show you the compelling reason why. The process industries, whether it's upstream, downstream, converted chemicals, or even specialty or converted chemicals, have similar challenges, different technologies, but similar challenges in process safety. Many different hazards. The consequences of these hazards can be very catastrophic, not only from property damage, but specifically environmental impact. And though we try to avoid it, fundamentally we are putting people in harm's way in some cases. And there have been a number of incidents, which I do not need to mention, where we've lost lives as part of the inability to detect abnormal situations and react in a expedient manner to prevent major catastrophic incidents, even though we have significant modern technologies to apply to that solution today. So my premise to you today fundamentally is we have those technologies and even more sophisticated technologies coming forward, but we are lacking the integration to integrate man, machine, and methods, much like you saw in the Shell solution, where you have real-time information coming in, you've got manual procedures or SOPs, and you have fundamentally automated solutions or information systems to fundamentally coordinate this activity and respond in real time to prevent catastrophic failure. So the challenge I'm posing you to today is we should look at what is available today and take a holistic, integrated approach to this closed-loop decision-making that you saw Shell propose. In a recent public forum, the deputy director of OSHA, roughly 2 years ago, was at Texas A&M, made a quotation fundamentally. They're looking at fundamentally the OSHA PSM and OSHA injury frequency data and looking at this and saying fundamentally, we've done a great job since OSHA PSM was promulgated in 1992, but we're making no progress. Progress has stopped in process safety improvement in our particular industry. The lagging indicators, the things that all of us have to report to the federal government, are indicating that fundamentally we have a problem that's not being addressed. And the premise by the deputy director is our metrics and our ability to measure in real time to predict and mitigate incidents preemptively is lacking. And as somebody in the industry, I'm looking, we have a lot of this information, but somehow we're not putting the power of that information together to handle abnormal situations, be they routine or non-routine. As somebody who worked most of his career in operations, I thank you for acknowledging our rigorousness in procedural execution. But I will tell you, it's not good enough. Zero is the answer for process safety incidents. Zero is the answer for injury, illness, and death. We must take it to the next paradigm. But the lagging indicators, as I will show you, say we've hit a wall for some reason. The response to abnormal conditions such as mechanical failure, process upsets requires a unique combination of equipment design knowledge, coupled with human cognitive skills, people recognizing the information, making a clear-cut, the right decision, and then being able to execute in a real-time domain to prevent adverse situations in your plants, be they environmental, health, or personal safety. How have we tackled this? Since OSHA PSM came into being in 1992, a number of us have taken different approaches in different orders of sequence. This actual slide is a copy of an Exxon presentation given last year at the ARC conference in a similar format. It comes actually from the International Oil and Gas Producers Institute, but fundamentally it says we have been successful in our process industries at reducing the rate of incidents over time, specifically over the last 20 years, by taking several different approaches in different orders, be they management systems, automation systems, information systems, or even human factors analysis for abnormal situational detection and correction. Whatever order we choose to implement in our various companies, we've seen this progress. However, non-integrated solutions to doing this has caused us to reach fundamentally an asymptote at the end of this lagging metric here. So the question from the deputy director is, what are you going to do now? People are still getting hurt. We are still having catastrophic incidents out there. What are we going to do to solve this particular problem? More evidence of this condition out here. This is not supposition on my part. This is data that is collected by the American Institute of Chemical Engineering, which we voluntarily, a number of us voluntarily report to and collect OSHA PSM incidents. It does coincide with the Oil and Gas Institute. Fundamentally, we are seeing a frequency rate declining. However, if you do the mathematical analysis, you see that it's an exponential decay, and we are reaching this asymptote. Even more concerning to OSHA, to myself, to the companies that I've worked with in the past, is this graph. Sorry for the background. There is an inflection point. If you take the derivative of that injury incident frequency, you will find that there's an inflection point, not just in any one company, in all the reporting entities to OSHA, that fundamentally, on or about the time frame of 2008, something has happened fundamentally. The injury frequency is going down and reaching an asymptote, and those that are incidents that are happening are much more severe and much more catastrophic, costing us money, people, environmental insult. We can all name names of the major incidents that have happened. So the incidents are going down. We have tackled the frequency, but we have not tackled the severity. And the problem with severity is it has real-time implications to it. The ability to detect and respond to abnormal situations in real time and act in a consistent, standard, and approved manner is a challenge for us. In the incident reviews by the Chemical Safety Board, fundamentally we're seeing that a combination of the three man methods or materials together as an integrated solution tends to be the problem. You know, it's easy to finger point saying it was operator error or it was a bad procedure, but we are ferreting those out. And what's happening is that the very severe ones are some integration combination of those three elements and the ability to tackle that problem. So, whether we've attacked the problem in three different perspectives or unified, fundamentally there still is a problem out there. And the problem, my premise to you is that we are lacking integration. So there's lots of data, but it's not being assimilated together in a standardized way in a timely fashion so that you can respond quickly and prevent or mitigate incidents. I'm not going to bore you with more statistics, but fundamentally, Dave Wall provided this to me actually, and it comes from the Oil and Gas Institute. You can see that, you have issues with machine failure, you have issues with the actual technology or process that you're handling, and you also have the human element that needs to be addressed. And there's not one overriding factor. It's not always the operator. So how do we tackle this going forward? 90%, this is from the Process Safety Congress, 90% of the accidents or defects or deficiencies are in the actual execution of the procedure. And 70% of these involve miscommunication, the wrong information in the wrong context at the wrong time. Sounds like a technological problem we could solve, but we're not pulling that together right now. Yes, some of the incidents have issues around workforce fatigue or the aging workforce, meaning lack of skills or experience in performing those tasks. That's not something I choose to discuss today, that particular factor. But a huge percentage here has to do with how do we detect, analyze, and execute the procedures, whether they be automated or manual, as in a workflow process. How do we do that in a consistent, and replicated, and timely manner? More analysis. The one point on the slide I'll bring to your attention is these are fundamental analysis, root causes of particular incidents. I want to point you to the third bullet, complexity of task. Shell mentioned that also. Our processes are very complex. They're multidimensional, multivariant. And to get at the complexity of the task from a real-time perspective, we need predictive analytics to take all of the factors and parameters into consideration and analyze them and present them in the format that the workers can take action in a standard fashion. We have the capabilities today to assimilate in lots of both manual type information, typed or entered in various fashions, as well as historized information in real time. But putting that in a context and be able to assimilate it in a rapid manner is the challenge being faced right now. Other elements or conditions that are involved, the work process, as Shell described, and how you do that in a consistent fashion needs to be systematized. He used the term workflow engine. We need to systematize the way the response or mitigation is acted upon. We also have to have human interfaces, the way you deliver the information, where you deliver the information. Things like mobile technologies are now making it more readily available for the person in the field to have the most current and accurate information in their hands to make decisions. What I'm asking is to take it one step further, present that information in a context and predictive and analytically predict what the response should be in a consistent manner. And most importantly, those actions that are taken, nothing happens in our process industry in a vacuum. Communications is ultimately important. The actions that are being taken, whether they be manual or automated, need to be synchronized and coordinated. That means that if a device in the field does not have an I/O attached to it, but there's a manual action, that manual action and the information or confirmation of that needs to be synchronized with the real-time control system or solution. So what I'm asking for, what I'm posing the challenge out there is we have the technologies, we have experience in all three domains here, but it's lacking integration, system-level integration of the man methods and materials to take that information and use it for both routine and non-routine tasks, integrating manual and automated procedural actions to fundamentally change the paradigm of process safety performance. And folks, this is not one company's information. This information comes from authorities, AICHE, Oil and Gas Institute. The data is there. The challenge is being presented to us by the regulatory agencies, and I will tell you, they are watching our response. What are you going to do with this? They do not believe this is a technological problem. This is a problem of a management decision to implement these solutions and make a paradigm shift in process safety. They praise us for what we've done since 1992, but it's not time to stop. It's time for the next paradigm. So I believe predictive analytics is a method that could be used to attack this problem. I won't get into the solution space. Fundamentally, what I want to leave you with is the call to action. We can do this. You've seen technologies presented today. You've actually seen solutions like Shell has presented where on the leading edge of pulling this all together. As an industry, the process industries and allied industries, I think we have the challenge that's been thrown in front of us to fundamentally take this to the next paradigm. So I'll leave you with that challenge. And think about it in light of solutions like you've seen from Shell and others that I've seen during the conference so far. And let's take that challenge and respond. So back to you, Mark.